and a very good day to everyone that stopped by. I'm Divya and I work with HSBC as a senior systems administrator. Um, so, in my daily job, I am a production support specialist, which means most of my day is spent sitting on crisis calls, troubleshooting issues in production and development estates alike. I also, I'm actively involved in providing root cause analysis and helping, reduce the number of recurrent issues within our systems. Um, and co- uh, Contributing to the efficiency overall in the way we respond to such production issues. So, over and above my daily job, I'm also actively contributing currently to several open source communities. Um, One of them is Kubernetes, in which I'm the release dog shadow on the release 1.19 team. I'm also a part of the upstream marketing team, wherein I just joined that recently. So I will be blogging about Kubernetes projects, Kubernetes sub projects, and areas surrounding Kubernetes governance, etc. Um, I'm also SigDocs lead on the Litmus Chaos community, which is one of the tools out there to introduce chaos into systems. So there are different tools. One of them is Litmus Chaos. And I also am an AWS community builder, and the program went live a few days ago. So as part of this, I actively work on AWS the AWS Amplify product, which is open source, and I currently, with my limited knowledge, I'm working on bettering the documentation for the AWS Amplify product as and when I scale up on that. So that's a bit about me. Uh, Having worked on a variety of systems ever since the start of my career, I've never heard actually anyone saying that they love being part of production outages or being on call during production calls. Because let's face it, as challenging and exciting and nerve-wracking it is, um, failure is not something humans actively prepare for. Maybe as a retrospective action, we do mull upon why it happened, but it's not something we um, respond well to given a surprise situation. Um, and as the VP and CTO of Amazon says it way better than I do, everything fails all the time. So the element of uncertainty and of failure is always there. And during outages, when it becomes difficult to pinpoint where exactly the failure has occurred, why it has occurred, how to go back to the normal situation for the system, um, it becomes it becomes a little nerve-wracking for all the personnel involved. And chaos engineering is a recent discipline that focuses on helping us eliminate this uncertainty to some extent. But before we go ahead and see what chaos engineering is, um, let's actually shatter a few myths about what it isn't, because knowing what it isn't is equally important. Um, and before knowing what exactly chaos engineering stands for. So, first off, it isn't about breaking stuff in production randomly. That by definition is mental and should never be encouraged, to be honest, irrespective of the environment or the system that you're working on. Um, it is also not a substitute for testing, or another word for testing, because I don't think testing requires another word to exemplify what it means. Um, Chaos engineering and testing are two fundamentally different disciplines with some overlapping principles, and we shall see how in the upcoming slides. Um, Also, it doesn't really exclude people or processes, or also isolate them via automation. So yes, there's a fair bit of automated processes that are there during game days or chaos experiments, in the way we introduce chaos and in the way we recalibrate our response to them. But it requires, for a successful game day, there is a clear requirement for the people, processes, and automation to work in tandem, because without that, you know there's not going to be a lot of success that you achieve out of a game day. um, and lastly, it's not a quick fix for poor design policies or processes, because nothing is actually a quick fix for that, and you need to ensure that while building an application or designing a system, you follow a particular way. I mean, you follow the best practices and design it, and deploy it appropriately, because there's no quick way to get out of a problem once it's in production. Uh, Now that we have looked at what it isn't, let's run through the definition, or see what the definition is per the principles of chaos.org. So, according to the principles of chaos.org, chaos engineering is the discipline of experimenting on systems in order to build confidence in the system's capability to recover from turbulent conditions in production. Now, what it essentially means is that being prepared in advance to um, to recover from outage-like situations in production by introducing conditions of chaos. Now, conditions of chaos essentially could be a lot of things. It could be latency, it could be erratic system behavior, it could be erratic network behavior, and a lot of other things. So, because today's topic is chaos engineering in a serverless app in a serverless world, we will primarily be focusing on chaos engineering in a serverless context. Um, Now, the inherently distributed nature of a serverless application is its kryptonite. Um, Response time lags originating from third-party API calls in distributed systems significantly add up and snowball into an eventual degradation of user experience with increased lag times. I mean, um, um, over and above these lag times, sudden hiccups in your network or in your system can also generate unpredictable reactions in the serverless systems, uh, which is also why there's an increased need, with the shift in focus to serverless, to build our defenses by emulating this erratic behavior and planning ahead as to how we would recover if this were to occur in real time. So, how do we do that? Typically, in chaos engineering, we function with the help of monkeys. So, Chaos engineering focuses on introducing different types of latency into the system, um, whether it be network, system, uh, etc. So, for example, one of the one of the experiments that I started my journey out with is well documented on the Thanja blog, and I would highly recommend you to go ahead and check the code snippets out. It is available over a quick Google search. So what that implementation of a latency monkey does is that it introduces latency issues into our serverless applications at random, uh, to effectively calibrate our responses during a real life attack. The implementation actually uses a set of lambda functions, in which one version uses flags in the calls itself to trigger the latency. And being a simple function, it's extremely simple to implement on a localized pet project, which is what I did. And I would highly recommend folks to try it out if possible, and if you're interested. So that's the bit about chaos engineering in a serverless context that I spoke about from my personalized experience. But you may ask, what's next? Where do we go from here? So at an enterprise level and at a personal level, we start off small. We start off with really small experiments. We start off with things as simple as um, you know uh, pods in the cluster getting deleted automatically, which is what exactly Netflix did with its Chaos Monkey. It also started with very small, with a very basic stuff like shutting down its ECS instances, deleting pods of its cluster, and calibrating high CPU usages. All of that contributes a step forward in your chaos journey. And at an enterprise level, you know, propagating this discipline in terms of introducing game days and simulating chaos experiments on lower level systems, lower level environments would be a step forward in the right direction for chaos engineering as a discipline to be introduced into your organization. So that's about it, and thank you once again for attending. I hope you guys have a great day, and I guess I'm available on Twitter and LinkedIn. The links are in the slide. Hope to see you there. And if you have any doubts, do reach out to me. I'll be happy to help you. See ya, guys. Bye.